Lesson number 3, Radiating Energy. By the end of this lesson, you should be able to describe and explain the term intensity, and know and be able to use the equation intensity equals the power of the incident radiation divided by the area, I equals P divided by A. And use the word radiation to describe any form of energy originating from a source. And know that the intensity of a radiation will decrease with distance from source. And know that the intensity of a radiation will decrease through a medium. In science, radiation is used to mean energy spreading out from a source. Radiation can be the harmful emissions of radioactive materials, but can also mean everyday radiation such as light from a light bulb. The light energy radiates outwards from the source. Ionizing radiations cause ionization of matter. They have sufficient energy to knock electrons out of the atoms of material, forming ions. Radiations such as light and sound do not have sufficient energy to remove electrons and so are called non-ionizing. The strength of a radiation is called its intensity. This is the power of incident radiation per square meter and is measured in watts per meter squared or milliwatts per meter squared. Intensity equals power divided by the area. Energy spreads out, getting less intense as it moves away from a source, as shown in the diagram. In the orange sphere, the radiation has spread out to an area of one small square. The green sphere is twice as far from the source as the orange sphere. The energy has spread out further to an area of 4 squares. The red sphere is 3 times as far from the source as the orange sphere. The radiation has spread out to cover 9 squares. If the source is emitting radiation continuously, the amount of energy passing through the orange sphere per second is the same as the amount of energy passing through the green and red spheres per second. If the intensity at the first square on the orange sphere is 72 milliwatts per meter squared, then all of that energy will continue into the green sphere over an area of 4 squares. The 72 milliwatts will be shared equally between 4 squares, i.e. each square will have 18 milliwatts. This means that the green sphere radiation is a quarter of the original intensity. When the radiation reaches the red sphere, the original energy is now shared between 9 squares, that is 8 milliwatts per square. The intensity has decreased to 1/9 of its strength at the orange sphere. When the radiations used for medical purposes pass through the body, they are not in a vacuum, they are in a medium. However, there is a small pattern of decreasing intensity. Each material in the body reduces the intensity of the radiation by different amounts. Bone is dense and reduces the intensity the most. Muscle is less dense, so it does not decrease the intensity as much.